Hello, chemistry students. Today we are going to learn how to draw structural formulas of molecules. And these are covalently bonded molecules, not ionic bonds. Okay, so the first thing we're going to review is how to draw the dot diagrams of different elements. Remember that you determine the number of valence electrons, which is easiest to do using a periodic table, write the element symbol, and draw the valence electrons as dots around the symbol. We'll start with hydrogen. It is a group 1 element, so it has 1 valence electron. Boron is a group 3 element, so its dot diagram will look like this. Carbon is in group 4. And nitrogen has 5 valence electrons. The first type of covalent bond is a single covalent bond. So we have 2 hydrogen atoms, both with 1 valence electron. And when they combine, it will look like this. And as you know, scientists love to write things in faster ways, so you will also see it represented as a single line. So if you see a dash between 2 elements, know that that represents 2 shared electrons. Okay, so for fluorine, so we will represent the molecule this way. Or you could also see it like this. Now, each of these dots that are around the fluorine, those are called lone pairs, and they represent a set of unshared electrons. Hydrogen has 1 valence electron, and oxygen has 6. So there are 2 single bonds that are formed in the water molecule. Ammonia, or NH3, will be drawn this way. But this is also correct and also faster to draw. And then we have methane. The next type of bond is a double covalent bond, and a common molecule that has this is carbon dioxide. So carbon has 4 valence electrons, and each of these oxygens have 6. When the molecule carbon dioxide forms, you actually get 2 bonds that form between each carbon and oxygen molecule. These are also called double bonds. And you can draw them this way as well. Each of these nitrogens have 5 valence electrons. So each of them need 3 more in order to have a full octet. I'm going to let you guess what you think is going to happen to this bond. If you guessed correctly, you would have said that the nitrogen atoms form a triple bond, where they are sharing 6 of their valence electrons, and each one has a single lone pair on it. You could also write it this way. The last type of covalent bond that we should talk about is a coordinate covalent bond. Carbon has 4 valence electrons. and oxygen has 6, as you know. This is going to form carbon monoxide. So in this case, you can see that carbon only has 6. So it has 1, 2, 3, 4, 5, 6 electrons. It still doesn't have a full octet. And right now, oxygen does have a full octet. So oxygen doesn't really want any more of carbon's electrons, and it doesn't want to form any more typical bonds. So what oxygen will actually do is form a permanent covalent bond where it supplies all of the electrons in the bond. So it will look like this. You see the coordinate covalent bond can be represented by an arrow showing which way the electrons are being donated. You can determine how strong a bond is using bond dissociation energies. So chemists have heated up materials and measured how much energy, or measured in kilojoules, it takes to break apart 1 mole of substance. So if you're wondering how strong a bond is, you can look up a bond dissociation energy chart. I'm sure they're all over Google, or you could use this one here. And that way you would know how strong a bond is. And this one right here is missing. This is a triple bond. So you can see that triple bonds are much stronger than double bonds, which are much stronger than single bonds.